Hi everyone, my name is Paul Czarkowski at pczarkowski on Twitter.
And I'm Myles. I'm at Myles Steinhauser. You can blame my dad for the long last name.
Yeah, we didn't really understand Twitter when we picked those Twitter handles, obviously.
Yeah.
We both work at Blue Box, which we're legally obligated to tell you is an IBM company. We both work on, originally we were working on the OpenStack product that Blue Box has, and then we moved to work on some internal facing tools around supporting OpenStack, and we'll talk more about those. So basically, what we're going to be talking about is Blue Box Cloud itself, and we're going to be talking quickly about some of the very OpenStack specific tools we have, like Ursula and gift wrap. And then we're going to get into Site Controller, which we discovered was the only thing we didn't have an official logo for, so we picked something dumb off the internet. So Blue Box Cloud, as a project, it started in, I think it was 2013. And it's basically, our goal was an OpenStack private cloud painlessly. And we had kind of this warm, fuzzy goal of being able to deploy OpenStack within an hour anywhere in the world. And so that was, what do they call it, big, hairy, audacious goal?
Yeah.
So that was what we were going for. And we really wanted to make it, like, take OpenStack and take private cloud and make it like a consumer-based thing where, as someone who wants to use OpenStack, you don't necessarily want to run OpenStack. And so we would do that for you. And so we have an open source project called Ursula, which is our deployment tooling for OpenStack. And it is open source. It's very similar to the OpenStack Ansible project. They use containers, we don't, but a lot of the primitives and the way that we do things are very similar. OpenStack, it was said earlier that OpenStack is a very complex distributed system and it's really hard to install, and that is absolutely true. It's easier than it was, it's still hard. And even when you're using a good deployment tool like OSAD or Ursula or something, it's still hard because you have so many choices to make. And so one of the things we do at Blue Box is we have really strong opinions about things. So we only have one way we do Cinder and one Cinder driver. And by doing that, we cut down our decision tree and we go from thousands of configurable options to hopefully only hundreds of configurable options. And so that helps us build out very repeatable clouds because we're in the business of running lots of clouds instead of what a lot of other people are, which is one big cloud. And then you want to take what decisions you have less to make and what configuration settings you want to make, and you want to get robots to do the hard bits for you. So you sort of break those down into primitives where these are the bare minimum things I need to know so that something can go and figure out the rest of the things I want. And that's things like MAC addresses, IP addresses, what servers are going to run what roles and that sort of stuff. And then you kind of let, in our case, Ansible, go and figure out how to do the rest. We can install from source or from package as Ursula, and that's just so in dev we're doing from source, in production we're doing package, so we're a little bit more deterministic. And then we can and have done in-place upgrades of OpenStack since Havana, and part of the reason we've been able to do that is the way we've done source and or package source of our OpenStack. And then we have Ursula CLI, which is a wrapper for Ansible. It just helps us kind of tie in some of the logic we use to maintain a lot of OpenStack clouds, and has support for doing our CI and dev environments. So I can say, hey, Ursula, give me a CI environment on OpenStack, and it will load up a heat template and deploy it, get five VMs up and running, and then install a dev OpenStack on it for me. Or we do the same thing in Vagrant. So it helps us keep going with that sort of very repeatable, do it over and over again, always get the same result kind of thing. And then gift wrap is what we use to build our packages. We don't use upstream packages from Canonical or Red Hat or anyone. We build our own. And we do that because if we need to do a fast patch for security reasons or for something like that, we can do it without waiting for an upstream vendor. We also are able to do, we do it in Python virtual envs and we package those. And we put them in different places on the system so that we can have 2 or 3 versions of OpenStack installed on a machine and control which one we run by symlinks and services and stuff. So we can put all the bits down for the next version of OpenStack, and the upgrade is then a much faster process. And if you're using OS packages, you have to uninstall and then install the new one. And so it just makes it a little bit smoother. Oh, I meant to be on this slide. And we have Docker-based build tooling. We don't use Docker to run our OpenStack, but we use it to build our packages, and it's all through our CI environment because we do get a lot of performance increases. And then we have a YAML-based manifest, which kind of looks like this. So we give it some settings, we say where to put it on the server, and what projects we want to package up. So this is just saying Nova, saying where to get Nova from, what Git reference to use, so we're always using the correct version. And then we can specify extra pip dependencies and extra system dependencies that we want to put into the package so that we install the right bits when we install it. And we also we don't include init scripts or service scripts, and we don't have any config stuff inside of our packages. We let Ansible do that for us. And then Box Panel, really quickly, Box Panel is kind of the single source of truth for all of Blue Box. It's our CRM, inventory ticketing. It's where our customers come to do stuff. It's where our support folks go to look at servers and stuff.
And so that brings us to Site Controller, and that's actually what this talk is about, is how do we build everything else to support everything you saw previously. Running hundreds of OpenStack clouds around the world actually requires a lot of back-end infrastructure, which ends up being more interesting. So, like I said, Site Controller is everything else required to install, run, operate a Blue Box cloud in a hostile data center. Now, hostile is very interesting because that actually also means not just a soft layer data center, for instance, but also a customer's local on-premises data center that we may not have access to the internet, or we may with an entire list of ACLs. It gets complicated. So how do we package up everything that we require to operate OpenStack and stick it in theirs? So first, a history lesson. I love trains. Before Site Controller, it was just Blue Box data centers. We had a lot of shared resources, which are actually very useful, but we basically came out of a managed hosting perspective. And not just managed hosting, it was basically, Blue Box was a startup for 16 years. We need to make money, have to pay the bills somehow. So if you need to host something, maybe a Mac Mini or a custom Ruby project, we'll take it on and figure it out. That all changed then when OpenStack launched and figured out we need to create a product and a service, not just whatever is required to bring in the dollars. We had some interesting stuff though to make that happen with managed hosting, the Pixie install stuff, which was actually using Razor V1, and we had a switchport switcher, which was a Perl script that would reach out and basically do rancid config manipulation for switches, bandwidth polar that would just do SNMP, and all this got rolled back up in a Box Panel, which ended up being a single pane of glass for all the customers and our support folks. It was actually a very interesting solution. IPMI proxy was also a pretty cool one because we can route all of our authentication through Box Panel and the auth, and then that opens up a port and everything else required for a support person to get access to an IPMI device without actually having to log into a VPN or connect over TLS or anything. It was connected only from their machine's IP, their public, to IPMI proxy, and then did some switching. So I think we talked about some of this stuff actually meant to be on this slide also. And then the SSH bastion was something called Yama, which happened to be an OpenBSD box because it was thought to be more secure than Ubuntu, which may or may not. But it required us supporting 2 to 3 different platforms of systems. And so that's kind of what we try to move away from also. I did start a logging project when I came onto the team. And for a very long time, it was basically, it's not ready yet. Or we had a very few number of logs actually flowing into it. It all got better.
And all of that stuff worked really well, but it was very, very bespoke and hand-built. And when it was only in 1 or 2 data centers, that's not so bad, right? But as we moved on to more, we realized that we have to actually be a little bit better about it and move away from the bespoke stuff. And also moving out of our own data centers, we learned that some of the data center automation we needed, we no longer needed as we moved into soft layer and other data centers where things like that were already automated under us.
So Site Controller actually came out of a project that came in with a customer who was very interested in deploying OpenStack and operating it. And Paul was given about a week and a half of notice. We need to deploy in a customer's data center for the very first time. And we knew this was possible, so let's go make it happen. So he basically didn't sleep for a week and a half. They had essentially no internet. He walked in the data center with an external disk drive with our mirrors and everything else on it. This customer owned switching and networking, which is very important. And I think you would RSA to like VPN or something. Yeah, I didn't get access to that. And so the initial bootstrapping is interesting because you've got, how do you get IPMI? How do you actually bring a bootstrap host up and Pixie install? I think I actually went, sorry. Oh, that's right. We jumped ahead. So it actually seemed like a disaster to a lot of people, especially in the moment and like even the weeks following up to it. But circling back, they realized that there's actually a very interesting problem that we can solve, and it wasn't actually that bad. We had everything required with some more modifications and more expansion. Yeah. He was told like a week and a half. Auditing Ursula was interesting because we already had all these configurations pulled out and defined. So defining what apt repos, where they're coming from. If you didn't have site controller, we'd have to do a lot of resolving of problems. So we had Sensu server for monitoring. We had Elk already there. And it was basically a small group of people that eventually got formed. It was Paul, Craig Tracy, myself, and we banded together based on the previous work we've already done on infrastructure, like as needed basis to support OpenStack to actually build out the site controller project.
Yeah, and the only thing we were able to negotiate getting external access to was to PagerDuty, so that we could be woken up at 3 o'clock in the morning, which was like the only thing we didn't want to get access to. And so we had to put absolutely everything into the data center. And we wanted to make sure that we were like, well, we're doing it once. If it works, we'll probably have to do it a lot of times. So we wanted to make sure that we had it repeatable. So we took the way we install OpenStack with Ursula and applied that to all of the other tooling and built up a fairly hefty Ansible repo of lots of roles and tools to do all of the stuff like the Pixie booting, IPMI, all that sort of stuff, mirrors, Squid.
Let's see. And somehow it all came together. So basically ended up deciding for Pixie server, it's too complex to do a lot of the other fancy stuff, so DNS mask actually works really well for being a Pixie server, answers DHCP, has a TFTP server built into it. Apt mirroring got interesting. I think we went through like 5 different solutions, eventually settled on apt mirror itself, which is a Perl script that usually works most of the time. Apt repos, though, was an interesting problem. We didn't want to host anything. One of the core tenets of site controller is not being the single source of truth. We want to consume elsewhere and mirror it locally, but we don't actually want to provide anything that's specific. We want to be a single point of failure. And if we are, we have to then distribute that out amongst our own deployments. So we use packagecloud.io for all of our actual apt mirror repos, and then we mirror off of that. We use, I think at the time we were using Git core because we thought we had to mirror our own Git repos and GitHub, which we eventually moved away from. But at the time that this was deployed, we were always still using source installs. We actually didn't have all the packaging infrastructure in place. So this was one of those big lessons that led us down that path.
Yeah, and we also discovered we had, inside of Ursula, because we were used to always installing with internet access in our own data centers, we had a lot of stuff in our enterprise GitHub and stuff that we would reach in to grab tools from that we now couldn't get to. So we kind of did some not quite Git mirroring using Git web and Git core to try and handle that, while we also frantically tried to remove those bits from Ursula and actually package things up into pip or Debian or something else that we could actually put in a repo or a mirror.
And then, so everything else I need to talk back again because we only had the single tunnel. Sometimes we end up using Squid for reverse proxying all of our connections. Also for local caching because we've got anywhere from 4 to 100 servers that are pulling these same apt packages and such. Might as well limit that bandwidth over the VPN. And of course, Elk for logging and our Sensu integration that reached out to PagerDuty. And then we accidentally got bought by IBM. And things got kind of interesting. I mean, our CTO and founder, he chose to, and then we kind of got brought along for the ride. So the first step was scaling everything. They said immediately, we want you in all of the software data centers. We have all the stuff that you're going to need to go do from the 3 data centers we originally were in, 1 POC and like 1 lab, not including all of our Vagrant installs. And so it got interesting trying to figure out how do we actually take this core product that we've been using as infrastructure and actually turn it into a service with that's actually mature, something that you would want to run in production that you're not necessarily worried about, that you would consider a production offering. So we started to apply to the existing data centers, the auto installs, and then, so, and then we, so all of that, getting confused. We moved from all of this work that we're doing and decided we need more of a central control plane. Originally, you have to go to a specific URL for each data center that had the specific tooling for that data center. And it got very disparate trying to correlate issues and knowing where all these URLs were. We actually had a wiki page that had like 45 different domains for this tool, for this data center, and it got too complicated. Humans have only so much load that we can handle.
Especially at 3 in the morning.
Yeah. So we split site controller into central and remote. And with the goal of no machine at a remote data center should ever touch the internet directly. which is actually pretty interesting. How you end up solving that is lots of squid, lots of VPN. So central site controller contains all of our shared resources. So that's our single pane of glass. It has all of our mirrors. It has the Bastion Flaptrack, which is our event routing system from Sensu server out to PagerDuty or emails or webhooks. Remote contains all the data center stuff like Pixie we had talked about for the Squid proxy for reverse, Elk, Sensu server. Basically, we're trying to contain everything that that data center would require if the link ever got severed, right there, local, and we can come back in.
Yeah, one of our core tenets through this was to always make sure that if one component went down, the other stuff would work. So while we use Site Controller to do a lot of operations against our OpenStack clusters, if Site Controller goes down, we didn't want OpenStack to go down, and we didn't want to affect the customer. And so everything we were thinking about, how do we make sure it's decoupled enough that if we lose a VPN link or if we lose a site controller itself, OpenStack keeps working, or at least the remote site controller at the customer data center or at the soft layer data center keeps working.
And one of the other aspects of site controller is the fact that even though it is in the customer data center, the customer doesn't have access to the hardware or log into the systems at all. Same with OpenStack. And we're here to provide a service for you, and you consume that private cloud, but you don't operate it, you don't manage it. You just deploy your stuff on top of OpenStack, and it's essentially any other cloud that you would go for. So this is the core architecture of site controller and the split between the central and remote. On the left side, you can see all of the boxes that we kind of use for central with some of the tools we talked about, the IPsec tunnel down to our remotes, and then the actual remote site controller with further IPsec tunnels down to the OpenStacks. Now, you're probably thinking, why in the world do you have IPsec and VPNs everywhere? And you're not wrong. This specifically came out of the fact that deploying on soft layer, we found out we essentially needed to build our own overlay networking. But if you've ever done overlay networking, like in containers, for instance, you find out it gets very complicated. Now doing that with Neutron and OpenStack gets even more complicated. And as operators, you generally see complexity and you run away screaming. So even though we're doing this, it actually ends up being a fairly simple model because it's the same VPN tunnel with different VLANs and some different routing across the entire board. So it's the same pattern stamped out, which is the same thing we did with Ursula into site controller. We've got some repetitive patterns here.
And just go back one. So one thing to note, the remote side of it, the side on the left, is basically that is stamped out at every data center we're in. So if it's in soft layer, we have one of those. If it's in the customer data center, we have one of those. Because they're only facing us and only Blue Box accesses them, in soft layer where soft layer is kind of shared resources, we treat remote site controller the same way. So all of the logging information, all of the alerts and stuff filter out through a central shared site controller rather than stamping one out for each customer, because that would just end up being a ton of extra infrastructure that's not really needed. And it also means that for logging and metrics and stuff, we can kind of get an economy of scale and have a couple of big servers rather than lots of small servers, because we still need HA and everything on all this stuff.
And the deployment workflow obviously is very important for us. We want it to be repeatable, very easy, without much human interaction. And so we open up a template for ours, which is basically a stamped out template for dedicated or local or central control plane or other just vagrant projects and stuff like that. You modify about 40 different variables for, and then we use our next tool is a site controller generator, which takes that template and spits out the full Ansible vars that are required to actually go and deploy it. We tried pushing this down to kind of get rid of them, and the complexity ended up exploding interface. So a little bit of extra abstraction worked for us. We push out the VPN tunnel, bring that up, and then we can update the central control saying, hey, you've got a new remote available for you, and immediately push out that new remote, and then we validate it. We actually use server spec and a validation playbook to make sure that everything is successfully deployed as we expect, which we can run at any other point also. It's kind of nice with item potency.
And again, you can see we're running Ursula there, and that's our CLI that wraps our Ansible. And so Ursula is a project, but it's also the CLI we use to run Ansible, so it can get a little bit confusing. But we're talking about site controller and running Ansible against site controller to stand up and configure all of those.
And so speaking of some of the actual site controller hosts that we do, these are essentially host types that we've kind of defined. And these actually have different roles. If everybody looks at our open source Ursula project, we're very much fond of role composition to come up with an actual server. We don't just have a single bastion and a bunch of different tasks. A bastion's made of a hardened SSH server and these other tools. And so that's kind of what we're speaking about here. So we obviously have SSH. We also do our own two-factor auth using YubiKey. We have an open source project of how we do that, which if you have multiple bastion nodes too, it does a multicast between them, which is actually really interesting. So then you bounce between hosts, you always come up fine. Group-based ACLs, and we do SSH key injection with a SSH auth proxy. That's specifically so we can give access to a user to have that SSH group available without them ever actually seeing the root keys. That's a really big important point to point out, that we're giving people access without ever seeing those keys, so they can't copy them off to their own host and go run off with them. So essentially, even though it's possible for us to roll keys very quickly, we generally don't have to because they're never exposed to any employees and for sure never any customers.
And all of the users and what groups they have access to are controlled by Ansible. They're sitting in a Ansible Vault file. And so adding or removing a user is simply adding or removing a line from that and rerunning Ansible. So it's very quick to remove access to all of our infrastructure. It's like a few minutes.
Yep. And once you do log into our bastions, we're running TTY Spy, which this is similar to what we actually run. We don't actually have that open source yet. But it is essentially a C program that attaches and injects itself into your connection, which then has all of your, everything you type in and all the output coming back to you stored off into a secure log server.
It acts in a very similar way to the Linux command script, where it kind of just records everything that happens, and it just pipes that off to a server, which stores it in a encrypted directory, so that if we need to do auditing for whatever compliance issues or whatever, we can do that.
And so the IPsec tethering happens to run between, like we described, central site controller and remotes for dedicated, of course. And it's interesting because that's always a physical appliance in centrals. That's actually changing in our newest migration of moving our central to SoftLayer. We're essentially moving everything to Viata appliances now. And it's all software maintained. And those are all managed via Ansible, of course, too. I think you know more about the Strong Swan stuff.
Yeah, and so one of the other things we did is we wanted to make sure that we could emulate the entire thing in dev and in CI and in other places where maybe we couldn't put physical VPN devices in a customer data center or whatever. So we kind of looked around, and like StrongSwan / OpenSwan are kind of StrongSwan is one we used. Is kind of a good way to get that, and I think it's actually what the Viatas use under the hood. And so we wrote roles so that we could also do the same IPsec tethers between just like Ubuntu hosts acting as routers / firewalls. And so that actually works really well in some places where we're doing dev work with some other IBM teams and they need to see it, and they just wanted us to have it in a small little VM. And so we couldn't really put a physical firewall / VPN gateway in there. So that worked really well for us. And also in our CI environments, we just use that as well. Which is super useful.
Yeah, it gets really interesting actually having that as an option, because then we can take our central and remote infrastructure, and if we happen to have enough memory, can run it all in Vagrant. So we can emulate our entire production infrastructure right there on a developer's machine to understand correlated failures or how impacts. Control proxy is what sits in the central site controller. That happens to run Apache Basic Auth. That's kind of our back end. We started off with that and then eventually expanded into OpenID Connect. And that is provided by Box Panel Auth, which is our own internal authentication system. OpenID Connect is OpenID 2 with the workflow thing. OAuth 2.
Yep. And it uses the same YubiKey-based two-factor auth as well. So pretty much anytime we touch anything customer-related, we're going through that two-factor auth system.
And it's just a reverse proxy. We happen to love these everywhere. So you go to our control domain, and first path is BCN for this instance, which is essentially our data center, and then all of the tools that are exposed to our operators within that data center. It makes it really interesting because they just know the single domain to go to. They have a full, nice, pretty web page that shows everything. And this is, again, controlled and deployed by Ansible, which you can see here, just showing the locations and all of our remote data centers.
So we try and make all of our Ansible data-driven. So if you're changing something on a server, like you're mirroring a new package or you're adding a new site to the control proxy, it's just done by modifying variables and dictionaries in the Ansible inventory rather than modifying Ansible itself in the Ansible repo itself. And that means that it's very easy for someone who's not necessarily a senior engineer, who's more of the, just does lots of deployments and stuff, to understand and deploy and, stamp out, patterns on what to do and also documentation on what to do and how to do it.
And then a picture of what that actually ends up looking like.
Yeah, so you can see basically, this is shortened to make it fit, but basically each data center we have a remote site controller in, shows up in here, and has links to Sensu, the Elk stack, and any of the other stuff in that data center. And then, as we were saying, it all just kind of gets remote proxied through using path-based proxying, which mostly works. Some stuff loves to have absolute URLs, which makes it super painful, but actually most things just work. And behind the OpenID auth, it's super useful.
And so back to the hostile data center thing. We needed to install OpenStack with almost zero internet access. We can actually do it with zero internet access with a mini bootstrapper, but we almost always have to have the IPsec tether. That might be going away, but it's a lot of complexity we're trying to figure out how to do. And so, like we mentioned before, remote site controllers have no direct access to the internet. And so we use a combination of mirrors and proxies to accomplish that. And I think if we have bonus content, we'll get back to the mini bootstrapper. It's kind of a fun thing. So mirrors, again, we love Apache, or at least we know it better than anything else, for better or for worse. And we use apt mirror, drops it into a indexed directory. File mirror is just a bunch of Ansible that downloads files and, again, drops them in a directory. But then we're also using devpy, which is a caching PyPy server, which usually works until you run it in production with 100 OpenStack nodes in CI. So we threw Varnish in front of it, and that happens. Same with Gemini Box. And finally, Squid, actually, we haven't had issues with. We don't use it as a mirror, but again, just as a caching proxy to.
Yep. The other thing we use Squid for in the central site controller is so that we can proxy out to PagerDuty. So it's whitelist controlled, so it can only get to, I think, four different URLs. One is our GitHub, one is PagerDuty, and there's a couple of others that we absolutely need. And that way we can say to the customer, here is the list of the only things that will ever, travel out to the internet.
And then again, we've got more Ansible data-driven configuration that shows what that's like.
Yeah.
So IPMI, we almost never actually use it. We should never have to use it. And so when we do have to, software use the software native tooling, which is an SSL VPN, and they do sort of give you root access to the devices, not entirely. In local, we use the IPMI proxy I mentioned before, which uses some IP tables NAT, which works pretty well. And then we use IPMI tool itself, if anybody's familiar with it, from our Bastion hosts and our Bootstrap hosts, which have access to everything required on the physical network.
Just about everything we need to do, we can do through IPMI tool or through serial on LAN through the IPMI tool, so it's all just straight from the Bastion. Occasionally, something crazy goes wrong with RAID, and you have to get in, reboot and get to the RAID config, and that stuff falls apart underneath serial on LAN pretty quick, so we then actually switch across to the web console from IPMI.
And so we mentioned Pixie before. Originally, Blue Box was using Razor V1, so we figured, hey, maybe we could use this again, or Razor V2, or Cobbler. It's all terrible. So we ended up falling back to DNS Mask and Ansible, which again is data-driven for us. We can control the boot order because of Ansible and IPMI tool. We've got playbooks to actually go through and use IPMI tool to set boot dev Pixie on every host, and then reset it across an entire deployment of OpenStack nodes. So we can go from a single operator, not having a remote site controller deployed in a data center, to having a site controller deployed and even multiple OpenStack clusters probably within a single day, if not a few hours. It's a pretty powerful combination that way.
And you can see again, it's just a pretty simple Ansible dictionary listing our DHCP range for the Pixie server, a bunch of options around passwords, where our mirror is, etc. And then a list of servers, which are basically name, MAC address, the IPMI, and the OS we want. And then if we want the regular pre-seed or something special, and then whatever our network config is, and then it will just go and kind of take care of it all for us when we run it.
And so then, obviously, you have to monitor everything. We talked about, I don't think I mentioned this earlier, but Blue Box originally used Nagios and Cacti because that's kind of what was available. We decided in OpenStack that we did not want to go that route, so we've been using Sensu and Sensu Server for a long time. So then running that in our production with Site Controller, we have Sensu servers deployed everywhere. So OpenStack logs to the remote Site Controller logs to or monitors central Site Controller connects to our DR central Site Controller. It's just Sensu all the way down. So an alert train in the path happens to go from Sensu client to Sensu server to Flapjack, which then calls out based on our routing and notification rules to PagerDuty, email, webhook.
Yep.
It's actually kind of interesting.
Yeah, so we have the Sensu server at each remote data center, and then we have Flapjack in the central Site Controller. And that's kind of how we were trying to do it without Flapjack and realized it was pretty impossible, so we put Flapjack in there, and that kind of handled that. Don't have to send it directly from the customer out to PagerDuty. And also gives us some options to be able to say, okay, route it to a ticket or route it to an email or something instead of sending it straight to PagerDuty.
And another architecture diagram of what that monitoring looks like. I'm not sure. It's actually kind of clear. It looks more complicated than it really is, but that's kind of how it comes through. These are all the different clusters that have the specific components running within them. And more than happy to talk about this after the talk. Of course, with monitoring, you also need to do logging. And so again, it's the same kind of chain, except this time we have logging from remote Site Controller to itself because we want to keep all of that local logging traffic and information in the local data center. Make sure that if that VPN tether goes down or something, all the data is there and is always on a customer's on-premises. We don't want to actually take that off. And so Central also connects and logs to itself, usually in an encrypted manner because there's generally more regulated information there. We started with log/forwarder. It worked. There are some pretty amazing edge cases that we occasionally run into, but for the most part, it just was fine. Filebeat came along, which is amazing. Absolutely shift over to using that if you haven't already. The Lumberjack protocol is pretty interesting, except for network devices being pretty dumb. They only know syslog, and they will only always know syslog unless you're running some like crazy modern Linux networking stuff. So we filter everything. But it's funny because we haven't actually touched our filters in about 2 years. We haven't needed to for the most part. A log message comes in, we know it's from like syslog or something, it parses it out, and Logstash then just shoves it into Elasticsearch. Except for backups. That was kind of an interesting thing when we got talked about because it's Elasticsearch, it's a database, you know, we don't have problems, and if it goes down, it comes back up. Until you grow too big, we had to start retaining logs from 90 days to 270 to 365. And when you look at that, you're going from a 18 terabyte Elk cluster in every single remote Site Controller to maybe a couple hundred terabytes. That gets real expensive because it's all on disk or in memory. So we started looking at the Swift object store because we ran it already, and then found out that the Elasticsearch Swift plugin is actually abandoned. So then we've shifted very quickly to using the S3 plugin, which is where we're at now. And we back up to a sister project of IBM called CleverSafe. And again, another architecture diagram. It's just the normal Elk stack happens to be running in our different components and our reverse proxy in Central that links back to it for our operators.
So the other thing we didn't mention, which we probably should mention back on the monitoring page, was that we run Graphite for all of our metrics. And so that sits alongside Sensu at each of the remote data centers. And we have Grafana to display it, which is all proxied back through the central Site Controller.
And then also if we have any Sensu checks that query Graphite, they're all within that local data center also. So we keep everything as essentially within the L2 domain as much as possible, actually. So that's actually what we had to in case we need to cut this short. But I think we still have a decent amount of time from what we're scheduled for. So we've got bonus content. As we mentioned, how do you actually roll into a new server and a new data center without having a presence there previously, when all you have is essentially a laptop? And so that's where you get to the mini bootstrapper. So that is taking essentially one of our or an operator's laptop that runs Vagrant, that happens to run the Bootstrap system on it, and then bootstraps a physical Bootstrap host, which then bootstraps the rest of them. So if you kind of think of it as like a blossoming flower, it kind of just does that a bunch of different times. Yeah. It's the same code just being run in a different context, pointing at different hosts. Now I've been playing with, instead of just using Vagrant for this, I can do all of this off of like a Raspberry Pi, which is kind of a nice out in case we really bone ourselves in a customer data center. We can overnight something, they plug it in the network, and we can get back access. The alternative to this, we've been partnered with another, essentially a company who actually we shipped all of our hardware to now. Oh, that's probably true. We ship it all to them, and then they install Ubuntu before we ship it out to the customer. And I also really like to make bad decisions. And one of these happened to be site controller generator after deploying, I think, 12 different remote site controllers in about a 2 weeks time. Before we had this, it was actually manually updating about 400 variables manually every single time, copying and pasting. And I knew Ansible really well. So I also grew up with Exhibit, and I used Ansible to Ansibilize my Ansible, which essentially means we're using an Ansible project to template out Ansible variables, which then get consumed by the site controller and Ursula and everything else. So we originally have probably over 1,000 Ansible variables, which we rarely need to tweak, but they're absolutely specific to different environments. So we've got 30 of them. We went from writing inventory from scratch for a long time. The copy and paste got faster. And now with Generator, we can just set what matters between the different environments. Central versus remote versus whatever product happens to dream up next, which is coming. And like I said, about 400 lines, 20 variables. All of our TLS certs and everything also are automatically generated. All of our passwords are automatically generated in a secure manner. So a lot of that stuff that's manual that you need to make sure for compliance, it's all taken care of, guaranteed every time. We can also read from the worksheet that our local, which is our on-premises offering, gives to us, which is basically a ton of MAC addresses, and dumps it into our variables, and same with SoftLayer API. So one of our core tenets, of course, is just always automating, always getting faster, and we end up writing a lot of kind of manual scripts to get around these processes.
Yeah, so we went from thousands of options to just a few. With that, I would say we probably have five to 10 single line settings per data center we're in to describe what that looks like, which is pretty cool.
Yep. And you know about compliance.
Yeah, so compliance. One of the things IBM really loves is compliance. We have a lot of internal compliance around, what a server needs to look like, what your OS needs to look like, and what all your files in your OS needs to look like. And so before we were acquired, the group had these things called tech specs, which are these massive Excel documents listing out every single thing that was needed for a compliance, on a file-by-file basis. And it felt like it would be pretty difficult to do one by one, go to all our servers and go through these Excel documents and make sure everything matched. So I was like, okay, let's take those and condense them down to something that we can read as a human, like a YAML file or something, and just describe them in an individual way, and then translate that to something we can actually test for. And so we had those converted to YAML files, and each one had a unique key. And then we went and wrote server spec checks to check for each one with that unique key in the name. So now you can run a playbook that runs server spec, and it will spit out, hey, here's 4 things that are no longer in compliance on this server. Etsy password is no longer owned by root, or whatever. And then so we were able to hook that up to Sensu so that we actually get, I think it runs hourly, the server specs. And so within an hour of something going out of compliance, we know about it, and we can get paged and action it right away. And then because we log the Sensu client logs to Elk, we have an audit trail of when it was run, what was out of compliance, and then when it was fixed, because the next time it runs, it would say the alerts would clear, and we would say, okay, it's been fixed. So we actually have a pretty interesting audit trail that just kind of automatically gets generated, which is really cool.
It's been extremely useful having that, because I think we've gone through 4 compliance processes so far this year, and the auditors have every time come back with some crazy requirement that we can go back and look in Elk, and it's still there for us. In continuous delivery, this is one of the things we always have to be shipping. If we're not shipping, we're not actually making features available in production. We're not actually fixing business problems. And so OpenStack itself, they're under a bit more complexity than we are from compliance. So they release quarterly. We like to release about weekly in different ways. So every time we're making a fix, and it may not be a full deployment for all the remote site controllers or central, but we can still do those tagged releases, get those updates out into production, and make them usable right away, which is a far more iterative process, and that's what we believe in.
Yeah. So basically, as soon as we have a feature or we have a change that we've done in Ansible, we will just roll it out across all of our 30, 40 remote site controllers that we have. And a lot of the times, we won't do a full Ansible run for it. We'll use the tags and limit and other things inside of Ansible to say, hey, only run the Elk node only run on the elk node and only run the update log stash tags. And so we can do very targeted deployments to hit specific features. Or we can just say, go run the whole thing, come back 10 minutes, and anything that was not fully up to date or that had changed since that last deployment would be up to date. And so because of that, we always try and make sure that you can always, like, no matter what state the remote site controller you're talking to is in, running Ansible to it will always get it to the correct state and upgrade everything and update everything. So we have a lot of logic through our playbooks to make sure that that's the case. Occasionally, with a really big change, like doing a major release update of, say, Elasticsearch, we'll have a separate playbook just to handle some of the really weird edge cases that you get into when you're upgrading a large Elastic cluster.
Which I just did a couple weeks ago, upgrading 35 Elasticsearch clusters in production with a single Ansible playbook and zero downtime as far as the OpenStack clusters were concerned. And that's it. 99 OpenStacks on the wall.
Any questions?
Sure. So you've got large amounts of clusters. How large? You mentioned like 18 terabytes to 100. How big is the cluster itself running?
Host-wise, we generally deploy a 2-node L cluster until we have to grow it and expand it accordingly. Our biggest cluster right now, I think that's actually running with full data, is about
9.
I think it's 9 nodes now. I don't remember exactly what cluster. I know the capacity for that cluster is about 18 to 20 terabytes of usable data. I think it's about 40 terabytes of actual on disk. Yep. And it's kind of interesting too how we actually route all of our OpenStack logs. So because we're using log/forwarder and FileBeat, we get to inject a customer ID and that cluster name in. So those get added to every single log that gets recorded. So we're essentially providing multi-tenancy within that single L cluster. There's some problems with that also that we know about that we haven't necessarily needed to address yet. But something.
Sorry, how do you handle multi-tenancy with your queries? I'm assuming that customers have queries.
They do not.
It's all us-facing. It's not customer-facing. We're exploring some options around making some of the OpenStack logs customer-facing because, let's face it, OpenStack, like when you run Nova Boot and it fails, it never tells you why.
It says 500.
Yeah, exactly.
Yeah. Or when you can't schedule something for some reason, no host is found. And so oftentimes we'll have customers opening tickets or opening chat with our operators, which is fine. It's okay because we, again, have that buffer zone, and then our operators are looking at the right customer. But since we've had these fields injected since essentially day one, when we explore this option with these essentially predefined queries in Box Panel, we'll be able to actually provide that in a very constrained form. Anybody else? Questions? Good. All right. Thank you.
Thank you.